Okay, today is the day second. So we'll see the types of the induced EMF. First one is the dynamically induced EMF, which is produced when a conductor moves in a magnetic field, and there is a flux cutting in dynamically induced EMF. Example of the dynamically induced EMF is the DC generator. Means the conductor is moving in the field. Formula of the dynamically induced EMF is the ED is equal to BLV sin theta, where B is the flux density, which is measured in the Tesla, and L is the effective length of the conductor. V is the velocity of the conductor. Theta is the angle between V and B. Here, the effective length or the active length of the conductor is nothing but the length of the conductor which is cutting the magnetic flux. Okay. Then the direction, Fleming's right hand rule. What does it tell? And the forefinger in Fleming's right hand rule indicates the magnetic flux. Thumb indicates the motion of the conductor, and middle finger indicates the induced EMF. Statically induced EMF, which is produced without the motion of the conductor, means here the conductor is stationary and the flux is time varying. Flux is time varying means d phi by dt. Example is a transformer. According to Fleming's second law, induced EMF is directly proportional to the rate of change of the flux linkage. What is the formula for the statically induced EMF is equal to minus n d phi by dt. Negative sign indicates the Lenz's law. Then flux, EMF, mmf, and reluctance, mmf, which is nothing but the magnetomotive force. mmf is equal to n into I, and flux is the ratio of mmf by reluctance. Here I is equal to V by R, and flux linkages is equal to n phi. Flux linkages are required to generate statically induced EMF. More turns, then more EMF. Faraday's law. First, what does the Faraday's first law tell? Whenever flux linking the conductor changes, EMF is induced. Second law, magnitude of the induced EMF is equal to rate of change of the flux linkages. First law, whenever flux linking a conductor changes, EMF is induced, means dy by dt is equal produces the EMF. Second law, magnitude of the induced EMF is equal to the rate of change of the flux linkage. Okay. And then the Lenz's law, direction of the induced EMF is such that it opposes the cause producing it, which explains the negative sign in Faraday's equation. It helps in finding the direction of the current. Why transformer works on AC only? AC is nothing but the time varying flux, EMF induced. DC is the constant flux, no EMF. Hence, transformer does not work on DC. Transformer basic construction. Active parts of the transformer, which are transformer core and transformer winding. Transformer core made of the silicon steel, and reason is the high permeability and low reluctance, which reduces hysteresis and eddy current losses. Transformer winding. There are two types of the winding, primary and secondary winding. Okay, copper is commonly used. Key differences: dynamically induced EMF and statically induced EMF. Dynamically induced EMF, conductor moves. In dynamically induced EMF, conductor moves, but in statically induced EMF, conductor is stationary. Then in dynamically induced EMF, flux cutting takes place, but in statically induced EMF, flux linking changes. An example of the dynamically induced EMF is the generator, and that of the statically induced EMF is the transformer.